Hi guys, I hope you're good since last video. Coding with an AI is not easy. We'll have a realistic view of how we would code using AI. We will use my current flow when building apps, some tips about what I have noticed. There is a paradigm change and we will see that. I use OpenAI ChatGPT just to be consistent and not to have to adapt to the million tools coming out each month, wrappers or not. How to code with ChatGPT. My personal flow of the moment. My example Rust AI cooking application architecture. My DevOps workflow for production. Let's get started. Coding with ChatGPT. So we're going to go through different flows and some tips and some explanations of a kind of coding with AI. Here I'm coding a Rust AI application, a mobile application. There's an easiest part, hardest part. Okay, there's the hard part that we're going to see. We're going to see the flows and the tips here and a little bit more. So let's start here with coding Rust AI app just to see what is the flow. So what we've seen in this channel, we learn Rust, we build project using Rust, we used previous language coding knowledge, we have mimic those systems, we use coding design knowledge. We are very opinionated. Okay, we have coding rules. So this is how you like to code, what you think is best, what is appropriate for your application. You're not making a 1 million user application. Code to learn more. We kept coding. So after entering into the ChatGPT interaction, you have to chat with it first about your project. Debate with ChatGPT until feasibility agreement is reached. At that time you have the context. Make the plan step by step, breaking down everything. Context, you get the step by step. You ask for a checklist of tasks. At this time you have your checklist. The AI has a checklist as well. Use scheduling and open several ones for each part of the plan, providing overall context. So parallelism. Come back later to read the different output and adjust if not agree. Okay. You play with it, providing output of one scheduled task to another. For alignment. So yourself, you know Rust or any language, user need, infrastructure, software development lifecycle. That's where you start with. You are not a coder anymore. This has changed. You are more like a senior dev reviewer of code, like the ones who just accept the PR request. You are product owner. You're also a client. Okay, project manager, you provide direction and vision, and you set objectives. Forget about coding yourself. You are not a coder. Okay? So what you need to know how to read code, how to spot issues in code, and the securities implication of some code. So you need to be able to spot that. Be patient and iterate. Okay? So minimal MVP. It's kind of useless. So have an MVP, secure first. Have an MVP with nice functionalities. Okay? How are you going to test something in which there is nothing to engage people using it? MVP has to be exciting to use. Okay, that's your first shot, something exciting to use. That was the easiest part. And now the hardest part. So you can know everything. If you don't get this part, you won't be able to do anything. Okay, you pass the door first of Android and Apple marketplaces to publish the application. You market your application, that's the hardest. This one here, marketing your application. Make video using it. Shorts, content, publication. Get feedback from first users. Feed ChatGPT with user feedback. Debate until agreement with ChatGPT, depending on what you want in terms of time spent improving your application and what the user wants. So here you need to decide, because you will need to maintain this application. So how complicated you want the application to be, because you don't want to be maintaining the application every day, every week, every month. So you need to decide on what is your involvement in this application, how much you want to give. Start thinking on implementing paid features that you figured out from user feedback and previous ChatGPT debate. So you get your free application with ads, and after you see how you can monetize it. Document step of improvement for marketing and content generation. So every step you can document it. Okay, making little videos, shorts for your marketing. Marketing is the hardest part. Update app with new features and keep looping through those feedbacks. Track metrics, downloads, usage, engagement, free to paid users, percentages. Analyze if hint exists in feedback. What is feedback? Anything is feedback. User comments, social media, the ratings, or the people you know that have tested your application, the comments, what you also think about the application. Your intuition is also involved. So that's the hardest part here, is the way you're going to be presenting your application and marketing your application. The tips, you're going to see that after, and the flow. So I'm going to start with this chunk, tips, coding with ChatGPT. More than 50%, let me place it like that, 50% to 70% of interactions are for planning. You need to have a long talk with the AI. I started with ChatGPT 4, it's fine, but one moment of when the conversation gets too long, you need to switch to ChatGPT 5. You'll be amazed to see how efficient it is, as it has a full context of the conversation. The output becomes sniper output. You really get what you want, straight to the point with pertinence. Do not hesitate, or let's say you must make recap checklist for checkpoints with the AI to see if it keeps track and adjusts by rendering the same with the adjustment details, so that the AI can use that as point of review of what needs to be done instead of going back far in the conversation. Checklist, use checklist. Also sometimes ask the AI to provide a canvas to be able to download it as a PDF, okay, of the project philosophy, the project rules, the objectives, any documentation, detailed checklist, what has been done, what is left to do. Now the trick here is to take that and port it to another conversation as starting point. As you know, when your unique conversation becomes too long, the GPT tends to decrease in quality of output. put all conversations in the same project. You can create a project and have all conversation related to the same topic in the same space. It helps being organized first and to have the context for the same project in the same folder. Do not trust, so always review the code, maybe not every single line every time. So at the beginning, the output something just to skim read it, as it is useless to go to the next stage if there is logic issues or misunderstanding. And after a group of code is made, now you need to stop and review line by line. At this time, you need to understand what's going on. Stop and read everything and not what you prefer, what you see missing, and so on. You make your own checklist on your side and then fix it with the AI and move on to the next. Do the same. Skim read, review line by line a group of interrelated code, and after you feedback to the AI and you move on. Keep the control. It's very important of the project features and steps, as I have noticed that the AI tend to understand what quality of application you want and start thinking of what would be cool to have and propose you the nice to have. So at the end, you're trapped into a feature increment loop, so it will never stop. So you stop the LLM to be that excited. Don't let it be too excited. Okay, you will lose track and never ship your application because you'll be just creating some extra features, feeling like it's never complete. Compile the full code or the group of and just check the kind of error you get. Import those errors, modules, for example, for me, missing S and so on, dependencies. So this will help you to review the project overall and see if all is well standardized. For other errors, instead of Googling, copy and paste in GPT and say that you have narrowed down the errors, and to teach you why those errors occurs and how to fix it. So use errors to skill up. Do this until it compiles. Other tip, after successful compilation of the project, do all unit tests with GPT. Drop each submodule's code and ask for unit tests to be written for you, run those, and pass to next module until you cover the full workspace. It compiles, unit tests are done. Now add logging at strategic areas of the application. Okay, so the idea from now on, as you got your minimal application compiled, unit test has safeguard of breaking changes, your strategic loggings. So ask the agent to always make unit test, then create the feature, then run unit test again, and adjust until the unit test assumptions pass. Then consider feature has done. That's how you get these decoupled tiny tasks. Here is an example of some tasks. Agent 1, harmonize all forms across the application to have this border, this center those, have this color, fix this button. Agent 2, fix the light to dark mode as it is not working for better accessibility. Okay. And the Agent 3, fix PDF download feature as the code is ready in the backend and the button present in front end, but nothing is linked. When I press the button, it doesn't work. Here you get decoupled 3 different tiny tasks, and they performed in parallel. Be strategic in how you prompt, as the GPT tends to be more and more lazy as the conversation goes, so summarize and open new conversation or ask more output from one prompt, not only focused in one step of the checklist, there'll be some back and forth to try in parallel if possible to gain time. So use parallelism for that. So when I use it too much, I feel like I'm throttled. Requests take more time to be fulfilled. I get more lags, like screen freeze, a few seconds, but this could be due to the conversation and prompts, as I can see that sometimes GPT tab takes more than 1.5 gigabytes of memory usage. My chat GPT dev workflow. Let's go to the flow after the tips. So you put new tasks, instructions in a file called agents.md. Okay, that's where you're going to put your instructions. After you open a new Codex conversation on Codex branch, you create a branch. I called it Codex in my project and ask to read the agent.md. Create a pull request. From your environment, you pull those changes into the same branch. So you switch to the agent branch. Mine is Codex. You compile. After here, there are two different cases, when it works, when it doesn't work. The error case, it doesn't compile. What do? What I'm doing, I update agent.md with the compile error, and I keep the initial task prompt. Git add, git commit, git push. I push to the upstream same branch, where the agent Codex is a plugin, is linked. And after here, I open a new Codex conversation and I just ask Codex to read that file. And it's going to start working, and it's going to come to compile. It's going to work. This is the case when it works. Test the UI, physically test it. And after I add, I just test the UI, and after I add a commit, I push. I merge the pull request to the Codex branch. I delete the agent branch because there's another branch created by the Codex agent. I switch to Codex and I pull the latest code. So sometimes I merge it to main. If big chunk of mini tiny features are done, I just merge to the main branch. Otherwise, when I'm done with this flow, I come back after this here. I come back to the beginning and I just put new instructions into the agents.md file. Okay, so that's the flow. It's a continuous flow iterating. My Rust AI cooking app, multi-platform. Let's go through that. There's some interesting points to see. Just to see, to give you some information about what it is. Cooking app, multi-platform, module, interdependency. We're just going to go through the architecture of it. I'm using workspaces. So I have a front end that I'm using Geoxus. And the backend is just the normal Rust code. We have a database, we have a prompt manager. So I'm going to focus here on core utils. Hold the application context that wraps any front-end database and holds the user settings. So it's an AI app, so there are some user settings. The SQL database, I use SQLite, hold all settings, receive, grosses, photos, prompts, AI suggestions. We have the prompt manager, the default system prompt, and we have a stored prompt template in database to be reused across sessions. Okay, so all the prompts are injected here. That's the settings, which is going to take the system prompts, and all the templates are created and put into the context. The AI engine prepend system prompt, like a wrapper, just for safety. Exposes LLM provider straight, a dispatcher that you've seen in the previous videos that I've done. I use the same concept here. Read user settings to know which provider to use. Okay. After we have the front-end application, the context that holds the database and special option of pages, components, app state context, exposes reactive UI, advanced settings, update, customize default prompt, create a provider instance from the application context. Okay, so we get the provider, and after we call send chat to obtain the AI completion. So the prompt, the AI is getting from the prompt and the need of AI response. This is just how all is connected. I'm using also an option for vocal input, speech to text. Okay. So the vocal input here, speech to text, download default whisper model, transcribe audio, device file storage, folder for models, 9090.bin, that's the model, and the temporary WAV file that is going to be converted to text. And the application, the app, this is the entry point to launch the application, and the binaries, compilation method, desktop native window via Dexus desktop, web just WASP via Dexus web, hosted in browser, and the mobile iOS or Android WASP plus HTML, then a wrap in capacitor and capacitor shell. So I'm just using capacitor. At the moment, that's what I'm doing. Code in Rust, I compile in WASP. I use capacitor as a wrapper, and the user gets exposed depending on the different platform. So that's how I have planned it to the application. And after from capacitor, I can deploy it into iOS or Android. We can maybe, after this break, go to that and just see how interesting it is. My simplified production pipeline, so my DevOps pipeline for Rust mobile app. I didn't put the test, I just put a simplified version, so we're gonna just look at it. Let me add here, simplified. Okay, so I code in Rust. I compile in WASP. I build with capacitor. After from here, I have two different solutions, two different roads, Android or iOS, MPX, cap, just building those, emulate in Android Studio or emulate in Xcode for iOS. This is to test, to have a fake mobile phone, or I just plug in my phone because I have an Android phone and I just check how the application look like in my phone. Deploy Ionic using AppFlow, so I'm using Ionic. Play Store or Apple Store, and after the user device, the user use the application. Okay, so it looks easy when we just talk about it and show those diagrams, but it's a headache, and that's what is interesting about that. Doing this headache, you're learning a little bit more. So this is how I vibe code. I don't like the term vibe code, but this is a code assisted, AI assisted coding. This is the term I prefer to use. And you got the tips, you got the workflow, you got what is hard and easy. We have seen that the paradigm has changed and that you almost don't need any more to code. You need to have some systems in place and improve those with time. If you are good in ideation and features precise explanations with some creative mindset, this is now closer to the public use than ever, when it has been gated for a long time. The ones taking more out of the ChatGPT and the consoles are the ones who already know the full development lifecycle. This is a time when the theory can help and when simplicity can help you to create your own utilities application for every day. Okay, let's stop here. Hope that you like this video. Please like and subscribe and see you next time.